So you still, let's say, familiar with some of these that we're doing today. There might be a couple of new things that you might learn or just refresh. Okay. All right. I still have people joining in. All right. So what does bivariant data is? So basically what that is when we have several several sets of data from one subject, okay? So let's say most of the time, we're gonna work with two, all right, sets of data from a single subject. So what do I mean by that? So let's say, for example, that you survey the age of a group of people, and then you want to know how far they can kick the ball, a football, right? So, so from one individual, you have two sets of data. One is the age, and the other one is how far they can kick the football, all right? It may be that those two variables are related or not, but you have two sets of data from the same individual. Does it make sense? So that's what bivariant data stands for. Now, the scatter diagram, that's how the book calls these plots. I think we just, or you know them as scatter plots, right? And when we look at scatter plots, then we want to look at these three things. We want to look at the association, and the association is the trend. And the trend can be positive or it can be negative, right? When is it gonna be positive and when is it gonna be negative? It's gonna be positive if the data has a trend that is increasing always from left to right, okay? So in this case, the association here will be positive, okay? And then the association here will be negative, because it's from left to right, is decreasing the data set. And then in this one, it's really not very evident if it's going in one direction or the other. You have a set of data here that is going down, you have something that is going up, another going down. So we will say that in this case, there is none, all right? Or there is no association between the data, all right? The form is the shape, okay? The form is the shape. Most of what we're going to do is about linear, okay? So that's gonna be if the shape is linear or not. Now, it depends on what we're doing. It could be that is quadratic of exponential or logarithmic, but right now we're interested just in what? Linear, all right? So, and then we want the strength, okay? And the strength is how closely these data points are. In this case, how closely they are or tied together they are with respect of the shape, right? So in this case, for example, this data set is very, very, it really resembles a line. So in this case, this will be a strong correlation or a strong association, right? So this one will be a positive, a strong association. This one, we can see that is going up, right? But the points are not really tied together. So the association is still positive, all right? But in this case, it's moderate. And then in this one is really weak. If we kind of draw a line like this or lines like that, we can see that this is going up, right? So this is still positive, but it's really weak. Okay, so when we look at a scatter diagram, then those are the things that we're going to look for. The association, that is going to be positive and negative. The shape, is it linear? and then the strength, which is a strong, moderate, or weak. Okay, that's the information we're looking for in the scatter plot. All right. So then here we said that correlation. The correlation R measures the direction of the association and the strength of a linear relationship between two variables. It can be given as a verbal explanation or as a numerical quantity. All right. A lot of times, what we say about the data set is based on the correlation, because the correlation will let us know if it's strong, weak, positive, or not. Okay. And that gives us information about how the data is, and if the two variables, how they interact with each other. Okay. Now, have you guys used this correlation coefficient before? What you probably have done is just look into the calculator what the number is, and based on the number, then make an interpretation of the data. Okay, that's basically what you probably have done in the past. Is there any questions so far up to this point? No questions? Okay, cool. All right, so let's look at the linear correlation of BBR rate data, including product momentum correlation coefficient. That's like a huge name for that. All that is the correlation coefficient, what you have used in the past and what we're going to refer to. Okay, let's say that's just the formal name of it. Now, when we try to do a linear regression, or we try to find a model for something that is linear, there are two methods. Okay, the one is the line of best fit, and the other is the correlation by product momentum correlation coefficient. Okay, we're going to focus on this. That's what we're going to do today, or at least start today. Okay, so what is a line of best fit? How is that? How that works? So let me tell you this. All right, really quick here. I'm going to use this example or this data set, that one. All right, if I were to find the line of best fit, so what we usually do is that we find the average value of the X values, okay? And then we find the average value of the Y values. So at some point, let's say that this point represents X bar, which is the mean of the X values and the mean of the Y values. Okay, let's say that point. So if we're doing a line of best fit, what we try to do then is use this as the guiding point. And then we're going to try to draw a line going through that point and as close as possible to the remaining data points. So I will draw maybe a line that goes through here that does something like that, okay? So this is my means of the X and Y values, and this is the line. And what I'm trying to do basically is to make the distance between the points and the line the smallest as possible, okay? This method, the line of best fit, is not the more accurate one, okay? So it's very inaccurate, as a matter of fact, when we compare it with the regression, okay? So the line of best fit, but that's the idea. We get these 2 points and then we try to move that line so we reduce these distances between the points and the line. Again, it's not the most accurate, okay? So we're not gonna focus on that, but I wanted you to know or have an idea how that is done. All right, so what we're going to actually focus on is the second method, the correlation by product momentum coefficient, right? Which is what we're gonna do. All right, so when we do a linear regression, all right, and mostly we're gonna use a GDC for that, then we actually want to have your book or our book call it response variable and explanatory variable. But actually, those are fancy names for dependent and independent variable, okay? The response variable is the independent. And one way to remember that is because it responds to the other variable, okay? So the explanatory variable is what we have been called before the, I'm sorry, I said that incorrectly. The response variable is the dependent, dependent, okay? Because it does response to the independent. So look at the example that you have here in these notes. It says that if a study is to determine the relationship between weight and blood pressure, then weight is the explanatory variable. So weight is going to be the independent. And then weight, if you are overweight or not, that is going to determine your blood pressure. So the blood pressure depends on what? How much weight you have. Make sense? So this is the independent or explanatory, and the blood pressure will be the dependent or response, right? The blood pressure responds to how much weight we carry or not. Here there is another example, I think. It said, if the study is to investigate the relationship between the level of fertilizer and the crop's volume during an agricultural season, then the level of fertilizer is the explanatory, that's the independent. And then the crop's volume is the response, right? So the crops are gonna either grow more or less depending on how much fertilizer we use. Does it make sense? So the fertilizer is the independent, the crop's volume is the response, okay? So how this actually works. All right, so I'm gonna share with you a video that will give you a visual how these things really work, okay? But as an introduction to that, let me tell you, I'll give you an idea, all right? So we're gonna have a line, and that line is not necessarily gonna go through all the points, correct? It might go through some points, but not all of them. So basically, the least square regression, what we are basically doing when we use the calculator is that the calculator finds the distance between a point and the actual line. Well, that distance really is an error, right? Because the line is not going through that point. So this is an error, this is another error, so on and so forth, all right? So what the method does is to try to minimize those errors. Make sense? So the least square regression, as the name suggests, least is the minimum error possible that we can make. And the way that that error is calculated is by drawing these squares and finding the area of those squares. That's what is called the least square regression. We really don't need to know much about how it works, but we need to know how to apply it, okay? So I'm gonna share a video with you guys so you have a better, I guess, idea of how this works. And then we're gonna try to do start at least an example or something, okay? So let me stop sharing this, and then I'm gonna share something else. So let me share with you this. Let me see. Where are you? Right here. All right, it's a video just from Khan Academy. Okay, are you able to see it? Let me just have the volume. And so this is kind of how this least square regression works. Okay.
Let's say we're trying to understand the relationship between people's height and their weight. So what we do is we go to 10 different people and we measure each of their heights and each of their weights. And so on this scatter plot here, each dot represents a person. So for example, this dot over here represents a person whose height was 60 inches or 5 feet tall. So that's the point 60, comma, and whose weight, which we have on the y-axis, was 125 pounds. And so when you look at this scatter plot, your eyes naturally see some type of a trend. It seems like, generally speaking, as height increases, weight increases as well. But I said generally speaking, you definitely have circumstances where there are taller people who might weigh less. But an interesting question is, can we try to fit a line to this data? And this idea of trying to fit a line as closely as possible to as many of the points as possible is known as linear regression. Now, the most common technique is to try to fit a line that minimizes the squared distance to each of those points. And we're going to talk more about that in future videos. But for now, we want to get an intuitive feel for that. So if you were to just eyeball it and look at a line like that, you wouldn't think that it would be a particularly good fit. It looks like most of the data sits above the line. Similarly, something like this also doesn't look that great. Here, most of our data points are sitting below the line. But something like this actually looks very good. It looks like it's getting as close as possible to as many of the points as possible. It seems like it's describing this general trend. And so this is the actual regression line. And the equation here, we would write y with a little hat over it. And that means that we're trying to estimate a y for a given x. It's not always going to be the actual y for a given x, because as we see, sometimes the points aren't sitting on the line. But we say y hat is equal to, and our y-intercept for this particular regression line, it is negative 140 plus the slope 14/3 times x. Now, as we can see, for most of these points, given the x value of those points, the estimate that our regression line gives is different than the actual value. And that difference between the actual and the estimate from the regression line is known as the residual. You write that down. So for example, the residual at that point is going to be equal to, for a given x, the actual y value minus the estimated y value from the regression line for that same x. Or another way to think about it is, for that x value, when x is equal to 60, we're talking about the residual just at that point, it's going to be the actual y value minus our estimate of what the y value is from this regression line for that x value. So pause this video and see if you can calculate this residual. And you can visually imagine it as being this right over here. Well, to actually calculate the residual, you would take our actual value, which is 125, for that x value. Remember, we're calculating the residual for a point. So it's the actual y there, minus what would be the estimated y there for that x value. Well, we could just go to this equation and say, what would y hat be when x is equal to 60? Well, it's going to be equal to, let's see, we have negative 140 plus 14/3 times 60. Let's see, 60 divided by 3 is 20. 20 times 14 is 280. And so all of this is going to be 140. And so our residual for this point is going to be 125 minus 140, which is negative 15. And residuals indeed can be negative. If your residual is negative, it means for that x value, your data point, your actual y value is below the estimate.
All right, so we're really not that concerned about the residuals and all that. All I wanted you to see is that all that the video is showing is what the calculator does for us, okay? But it's good to have an understanding of what is happening in order for us to get a regression. What he calls the residual is what I mentioned, that is the error that we're making, okay? So we want that residuals or that error to be the least as possible. That's why it's called the least square regression, okay? So let's try then to at least see if we're able to get part or the whole first example, okay? I need to change the video thing. Let me see. Now it's not gonna work. I didn't work at least. Content on the second camera, okay. And I want the content for the second camera, but it's not showing. All right, so let me pull the ladybug thing. That one always work. All right, so here we go. Hope so. Not good. It's not working either. Let me see. Settings. Sorry guys, this thing is. Let's see, I connect and disconnect this again. See if this works. Not a good thing. Trying to fix this thing. Okay. Can you see that? No? All right. So give me a second. Because before it was not even coming out. All right, so let me see. All right, so let's continue. So we're gonna enter this data into the calculator. I don't know if you had the opportunity to do that already or not, but just reviewing what you have done in the past, okay? So this is example 1, right? We're gonna enter that data into the stat. So go to edit, stat edit, and enter that data, please. And it says that we're going to enter that data and we're going to use the calculator to find the regression equation. So before we do that, I am going actually to graph the scattered plot. Okay. All right. So just, I'm going to say that you entered the data. All right. And I know you probably haven't, but just to try to at least finish this part. So I entered the data. L1 is the first column, the math scores, and L2 is the physics scores. All right. So we're going to create a scattered plot. So what you do is that you press second y equals. Okay. And then that takes you to the stat plots. There are 3 plots that we can use, right? So press enter to choose the first plot, and then you press enter again to turn it on. Now we want a scattered plot, so the type will be the first option that we have there, okay? By default, it will use L1 and L2. The mark is the symbol that we're gonna use for the scattered plot, all right? I'm gonna use that now, but usually I like to use the little cross just because it let me see the line better. But for now, I'm gonna use the square, okay? And before you graph, then what I recommend is do zoom and then 9 stat, because that will fix the window for you, all right? Otherwise, you have to look at the values of the X and Y and come up with your own window, but that will make it faster, all right? So, all right, so that is my scattered plot, all right? So let's look at this scattered plot before we actually trying to find a regression. What kind of association do we have?
Positive.
It's a positive. There's a positive trend. Is it strong, moderate, or weak?
Moderate.
Moderate.
Moderate or weak. Either one of those, right? We're gonna find out, really. It looks like it's moderate, right? There is some trend, and there's not a scattered everywhere, but there are scattered, obviously, right? Okay, so now we're going to run a regression. But before we do that, if I run the regression the way the calculator is, I might not see the correlation coefficient, okay? I need to turn what is called the diagnostic in order to be able to see the correlation coefficient. A quick way to do that is to go to mode. If you go to mode and you scroll down, here it says diagnostic, right there, diagnostic, and it's off right now. You need to turn that on, okay? So you move to on, highlight on, press enter, and then you will be able to see the correlation coefficient. If that is off, you won't see it, all right? So for example, if you're in a test and we ask you to reset your calculator, this is gonna be off. So as soon as you reset the calculator, then remind yourself, I need to put this on again, otherwise in the middle of the quiz or test or whatever, you're gonna like, oh, I don't see the coefficient correlation, all right? Okay, so once that is on, then we're gonna run the linear regression. You go to stat, you go to calculate, and there is no difference between 4 and 8. Either one is the same thing. We are used to mx plus b, so I'm going to use 4, okay? So I'm going to use number 4, and then it tells me L1 is where I have the x values, L2 is when I have the y values. There is no frequency list in this case. Now, a store regression, we want to store the equation, okay? So what we can do here, come down to a store equation, and I want to store that in y1. So I will say variables, what is that? Variables, which is down here, y variables function y1. And all I'm saying is store the regression equation into y1. And then now you will just run it. All right, so look, this R is the correlation coefficient. So it's 0.82. But 0.82 is gonna be a perfect correlation if that number will be 1. So 0.82 is kind of close to 1. So I would say it's moderate, all right? We're gonna find a criteria how to determine if that's moderate or not. But then if we were to answer A, right? Use the GCD to find a regression equation. I will say that A with 3 significant figures is gonna be y equals 0.796 x plus 6.63, maybe 7, right? Because it's 0 and then 6, maybe 1, right? Rounding. So this is my regression line. Remember that we stored this in y1. So if I go to y equals, I have the equation, but that equation has all the decimals that the calculator found for me. So obviously this equation is gonna be more accurate than this one, but most of the time you will be asked to use 3 significant figures, so you will use something like this, okay? So let's graph what we have. So now we have the scattered plot and the regression line, all right? It goes through there. Part B says, we found the regression, generate the scattered plot, we did that already, right? And insert the equation line from part A, that's done, that's what we just did. Describe the strength of the association between the exam's results in math and the exam results in physics. So let's do that. So it's positive, right? So there is a positive, because the trend is upward, moderate correlation or association between the math scores and the physics scores, right? So that would be example one up to this part. I want to just finish with this, at least today's class, okay? Then we're done. That's the criteria for us to determine if something is weak, strong, or moderate, right? It can be strong, positive, or negative. So it's moderate if it is between a little bit above 0.75, okay? If it's really, really close to 1, then it's going to be what? Strong, okay? This particular book gives us that, and there is actually these intervals. I just look into the other SL book, the other, no SL, I'm sorry, the other HL book, and that book in particular gives us these intervals. So if the coefficient is between 0.95 and 1, it's very strong. If it is between 0.87 and 0.95, it's strong. If it is between 0.5 and 0.87, then it's moderate. And if it's between 0.1 and 0.5, it's weak. And if it's less than 0.1, right, and that should be between 0 and 0.1. If it's less than 0.1, then there is no really correlation, okay? I think this is more telling, and it will apply the same way if the values are negative. Make sense? So that gives you a better idea of when to call it strong, moderate, weak, so on and so forth. All right, so well, that's all because it's 12:30 already for us, okay? Is there any question?
Could you go over what the quiz will be like?
Yes, like in terms of what? Like in terms of the questions coming or the format in which we're going to run it?
Both.
Both. All right, so Ms. Spears and I, we haven't really met about to decide the questions and stuff like that, all right? But I can tell you the idea we have to run the quiz. All right, so I don't know if I mentioned this before or not, but okay, so the idea to run the quiz is as follows. We're gonna give you a document probably 5 minutes before the actual class, all right? Meaning that it's gonna be in Canvas somewhere, you can download it and print it. And then you're going to, that's how you're gonna use those 5 minutes prior to the class. Then you're gonna log in into the class and you're gonna have the 30 minutes to do your quiz, all right? During that time, so what we are thinking to do and is the following. And actually I was talking with a teacher and she suggested something that I think is better. So I'm gonna make that suggestion to Mrs. Spears, but this is what Mrs. Spears and I will discuss, all right? So you go download the quiz, print it. Now you're gonna log in into the class and you're gonna have the 30 minutes for the class to do the quiz. So what's gonna happen then? So I'm gonna ask you to tilt your camera so I can see your paper and your hands at all times. So that means that you need to have everything handy, because once you sit to take your quiz, you are not allowed to get up and just disappear from the classroom. All right. So during the quiz, you're going to, I'm going to unmute you, but you're going to lower your computer volume. So I don't have that feedback, but I still can listen to what's going on around you. All right. So the 30 minutes are over. What you're going to do next is that then I'm going to open the Canvas assignment for between 5 to 7 minutes. And you have that amount of time to take a picture of your quiz, upload it into Canvas. Okay, and then after those 7 minutes or so, then the assignment is closed, and all your quizzes should be uploaded into Canvas. Okay, that's what we have thought of. I was talking with a teacher today, and she told me that there is something in Canvas called quizzes, that actually we can manage this differently. So I'm going to explore that, because if we can do all that in a more virtual environment, I think will be better for all of us. Okay, but up to today, that's the format we have discussed with Ms. Spears, how we want to assess you guys. All right. Any other question?
Do we get to use a formula booklet?
Yes, you do. So you need to make sure that you have one handy.